So we're picking up with number 4 on the slope field notes, just going point by point and getting the slope field. So my next point is over 2 up 3. So 2 goes in for y, or no, 3 goes in for y, 2 goes in for x, so that's negative 1/2. So I want a slope of negative 1/2. So there's a point over here that I'm sort of aiming at to go down 1 over 2. So there's my slope of 1/2. And there's my slope piece. Okay, you put all the pieces together, you get a slope field. At 3, 3, so 3 goes in for y, 3 goes in for x, negative 1/3. Okay, well this one I'm kind of eyeballing, although I guess I could aim backwards here, down 1 over 3. I mean, when I grade these, when AP graders grade these, they're not getting out, popsicle sticks and rulers to make sure that your slope is perfect, but they definitely want to see that the trend is right. What's going to happen at y equals 2? It's going to be a slope of 0. It doesn't matter what x is. So again, sometimes you hit an easy section where you don't really have to plug in everything. You recognize what's happening. Let's see, so 1, 1 would be 1 over 1 is 1. If I plug in 2, 1, so 1 for y, 2 for x, that'd be 1/2. So I'm aiming for a slope of 1/2. And then if y is 1, x is 3, that's 1/3. So there's my slope field. Again, just go piece by piece, plug things in, and put the little slope piece on. There, I don't want to say usually, 50% of the time maybe, it's a pretty frequent free response question on the AP test. And students like it, because like that part, you're going to get those 2 points, or however many points they put on that, you'll probably get those. Part B. Let y equals f of x be the particular solution to the differential equation with the initial condition f of 3 equals 1. Maybe 3, 1 is on our, that means 3, 1 is on the graph. Write an equation for the line tangent to the graph at x equals 3. Okay, whenever I see write an equation for the line tangent to the graph, I know right away that I need a point and a slope. And then I can write the line. And then I'll use that equation to approximate f of 3.5. Okay, so there's 2 things in this one. Write the line and then use the line. Write the line. Well, they gave me the point. 3, 1. How am I going to find the slope? What's another name for slope? Derivative. And they gave me a formula for derivative. So this one's a little bit weird, different than usual. Usually I have to find a derivative and then plug it in. But this one they gave me the formula for derivative. So all I have to do is find the slope at 3, 1. Which I kind of already did. It's that slope right there. I didn't write it down anywhere, so I guess I need to go back and figure out what it is. 1/3. So now I've got the point and the slope. I can write the equation of the line. So there's my tangent line. Now, the next question is pretty frequent, and it's a pretty frequently missed. How do I use that equation to approximate f of 3.5? What's that? Okay, get y by itself, and then plug in 3.5. And in fact, safe stop approaching, get y by itself. In fact, yeah, Ben's answer is perfect. Get y by itself, plug in 3.5, and then stop, like be done. y equals 1/3 3.5 minus 3 plus 1. And that's our approximation for f of 3.5. So we don't know what the function is. We don't know what f of 3.5 is. Thank you. But based on this tangent line, I'm going to draw more than I probably should. So that line would be, if we extended this line like all the way, there's our tangent line. And f of 3.5 would be about right there. But our function probably doesn't follow that exactly, but the idea is it's probably close to that, because we know it goes through this point, and we know it's this is the tangent line, so we would think that's a pretty decent approximation for f of 3.5. Part C. This is what we did Tuesday and Wednesday. Find the particular solution with the initial condition 3, 1. So okay, now actually find the answer. This is where we will use the SIC method. Separate, integrate, quantitate. So dy over 2 minus y equals 1 over x dx. Well, the separate's easy. The integrate, I think the right side's easy. Kenneth, what's the antiderivative of 1 over x dx? You've done it a few times this week. You've done the homework. You've done it more than a few times.
X.
It's not x. This is one we just have to recognize. Somebody help him out. What's the antiderivative of 1 over x dx? Natural log of x. Plus c, so it's on the x side. The other side is a little bit harder. Do you know what the other side's going to be? It's something close to natural log of 2 minus y. Why would it be negative? So the official way would be a u sub, u equals 2 minus y, du equals negative dy, and there's where our negative would come from. So negative dy, negative out front. So this one was, it's a natural log, but it's that negative sign messed things up a little bit. So negative natural log. I better be careful with this. I'm going to put it in absolute values, especially since 2 minus 3 is, I don't know. I might need it, I might not. Particular solution. And it's telling me I need to get it in y equals, so I need to solve this thing for y. So, remember this is the point where our calculus is over. Now we get to do algebra the rest of the way. You could do the e thing. I think I'm going to put the negative on the other side first, and then we'll e both sides. And negative 1 times c, still c, because we haven't figured out what c is yet. Then we can either do the fishhook thing, or e to both sides. That's kind of the same thing. 2 minus y equals e to the negative natural log of x plus c. C can go in front. Yep, that little algebra trick. So 2 minus y equals c e to the negative natural log of x. So something's going on with e to the negative ln, right? E to the natural log cancels each other out, but there's a negative in there, so that doesn't quite work exactly. Talk what? Yeah, I was getting sloppy with those, and I dropped them. Y is 1, x is positive, so everything's going to be positive anyway, so I don't have to worry about it on this one for this particular point. Yeah, I'm still looking at e to the negative natural log of x. I guess it wouldn't be wrong to leave it like that, but there's going to be a better way to do that. What's a negative exponent usually do? Let's go do it this way. Puts it in the bottom, so we could do that. So c over e to the natural log of x. And now we fix the negative. So what's e to the natural log of x? That's just x. 2 minus y equals c over x. Solving for y. I'm going to add y and subtract the c over x. So 2 minus c over x. Algebra, 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 algebra. And now I can plug in, now I can plug in 3, 1. It's always the blue pen step. 1 goes in for y. 3 goes in for x. Let's see. So 1 minus 2 is negative 1. Multiply both sides by negative 3. C needs to be 3. So y equals 2 minus 3 over x. Wondering if that fits with what our picture showed our answer should look like. 2 minus 3 over x. Yeah, I think if I tried to, maybe I changed my window to match my graph. Negative 1 to 4. Negative 1 to 4. Right? I think I believe that slope is that slope. Right? You see what I'm trying to look at? Match those things up. And even though I don't have a ton of points, I think it's believable that this graph would look something like that. So I feel good about that answer. That's probably an old AP test question, honestly, because they like to do those where you graph the slope field. That's pretty easy. Ask some random question where you use a derivative and use some other information, and then solve the differential equation. That's what we did Monday and Tuesday. So this is a good example of kind of putting it all together. Okay, so that means Monday and Tuesday's assignment was worksheet 1. Thursday, Friday assignment is worksheet 2. And I wonder if we should do one of these. Number 1 looks really similar to what we just did. Like nearly identical to what we just did. Why don't we try number 5? So turn to number 5 on the worksheet. And try number 5 on the worksheet.